Hello everyone. Drawing Lewis structures is our topic today, and what we're going to do here is draw these models of molecules according to a set of rules. And the model isn't perfect. What we'll do is we're just going to draw the valence electrons in what are called Lewis structures. And it has the way that you see Lewis structures is that it typically has a left and right and up and down type of thing. So you might have a bunch of things attached to it. Okay, that's the first thing I want to point out. And the second thing is it's important what you put in the middle, okay, versus the sides, okay? So a couple things when we draw Lewis structures is, first of all, you want noble gas configurations. So if we're going to go in noble gas configurations, we're talking about the S&P blocks. In other words, the main group elements. These are only for main group elements, okay? At least they should be. Typically, it's going to be the P block elements, okay? Now, two rules. The sum of the valence electrons must be fulfilled in the drawing. That's the first thing, and you'll see what I mean by that in a second. And second is everything's got to have an octet. Okay, if you can do that, then you're good. Hydrogen is an exception. It's going to have a duet. It's not going to have a full octet. And of course, helium too, if that ever comes up as well. Okay. The reason is it only has one energy level. It can't form a full octet. So here are some some steps in drawing Lewis structures. You can write these down if you think you need them. But this is a process, and the process is simply this. Look at the molecule, add up the valence electrons. The second step is decide what goes in the middle. The definition is that the least electronegative atom goes in the middle. Kinkoff's definition is that this thing that can form the most bonds goes in the middle. Now that gives you the answer most of the time, like 98% of the time. Okay, but that's not a bad rule. So the thing that can form the most bonds goes in the middle. That happens to be the least electronegative atom. Okay. Third thing, give everything an octet. Just slap an octet on everything. Of course, hydrogen is the exception. That's your duet. And then if you have multiple bonds, now you got to start erasing and doing crazy things. Okay, we'll get to at least one example of those later. Note, if you have extra electrons, you're going to add them to the central atom. Okay. Again, that's kind of like a more advanced type of thing. So we'll just keep that in mind. Okay. The first thing I want to do is talk about, before we get into Lewis structures, is we need to talk about electron dot diagrams, okay? So if you have something in group 14, it has 4 valence electrons, correct? Typical example is carbon, okay? So if I'm going to draw this, carbon has 1, 2, 3, 4, okay? Actually, let me redo that. Watch how I draw this, okay? You're typically going to add 1 to each side, and then if you have extra, then you double up. Now, I started at the top, but I can start at the bottom. I went clockwise, but I can go counterclockwise. It doesn't matter, okay? At least in the carbon's case, okay? So if I have 4 valence electrons, that's how it would look. If it's 15 valence electrons, which is 5 valence electrons because it's in group 15, it's going to look like this. Now, again, you can start anywhere you want, top, bottom, left, or right. I'll start on the bottom. 1, 2, 3, 4, and then double up, okay? Now, you could double up anywhere you want. This brings a different situation here. Nitrogen can form 3 bonds. You can form a bond here, here, or here. These are unpaired electrons. Electrons like to pair up, like in orbitals. This is called a lone pair. Lone pairs do not have any, there's no bonding at lone pairs. There's no bonding at lone pairs. So nitrogen, the way I've drawn it, has bonds on the left, top, and right. If I were to draw it like this, and again, so by the way, a line represents 2 electrons. Okay, I think that said it on the last slide. So here's electron, here's electron, a pair of electrons, pair of electrons, pair of electrons. Okay, so now this is the lone pair. There's no bond here. All right, let's do one more. So if I have perhaps oxygen, okay, oxygen has 6 valence electrons, okay, because it's in group 16. So here I have 1, 2, 3, 4, 5, 6. So where would the bonds be now? They would be on the right side and the bottom. This is a lone pair, this is a lone pair. There's no bonding here, okay? There's no bonding there. So let's try a couple of these. If I come across CF4, step number 1 is add up your valence electrons. Carbon has 4. Fluorine has 7, but there's 4 of them, so 7 times 4 is 28, which gives us 32 valence electrons. The atom that can form the most bonds is carbon. We just saw carbon has 4 valence electrons. It can form 4 bonds. Fluorine can only form 1 bond. So the thing that is the least electronegative, or Kirchhoff's rule, the one that can form the most bonds, goes in the middle. Let's arrange fluorine around it. So far I've drawn 8 electrons. 2, 4, 6, 8. Okay? So remember, a line represents a pair of electrons. It also represents a bond, too. I don't know if you picked up on that. Give everything an octet. Okay? So everything has an octet. That's our first check. Second of all, have I represented 32 electrons? When you count these up, there are 32 electrons, valence electrons, and that's a well-drawn Lewis structure. Let's try Cl2, not Ci2, but Cl2. That's in group 17. There's 2 of them, so that's 14 valence electrons. So I'm going to put them right next to each other. There you go. Give everything an octet. Okay, so now our process is done. Let's make sure we have our 2 checks. Everything has an octet. That's good. Have I drawn 14 electrons? You'll find that when you look at this, it is well drawn because it has 14 electrons. Try this one. Nitrogen's in group 15, that has 5 valence electrons. Hydrogen has 3 total valence electrons. 1 times 3 is 3, for a total of 8. Nitrogen has, I'm going to arrange it this way. I just gave nitrogen its octet. I did a little slightly out of order. So again, let me do this in order. Add up the valence electrons. Arrange the atoms around the one that can form the most bonds. Nitrogen's in the middle. Hydrogen goes around it in a top, bottom, left, and right type of way. Give everything an octet. I just did. Count them up. Everything has an octet. Check. Have I drawn 8 valence electrons? Check. There's 2, 4, 6, 8 valence electrons. Let's try this one. Add up the valence electrons. 2 plus 4 plus 6 is 12 valence electrons. The thing that can form the most bonds, which is, if carbon's ever mentioned, that's your central atom, period. Okay? So put carbon in the middle. Let's put hydrogen around it. Okay, you could have put hydrogen over here if you wanted. It doesn't matter where you put it. Okay? It'll move on its own, I assure you. Okay? Now, give everything an octet. So everything has an octet. Hydrogen has its duet. Remember, hydrogen's only going to get 2. And then count them up. So everything has an octet, check, or hydrogen has its duet, little mini check. Do I have 12 electrons? No, I have 14. So the model doesn't fit what we see in nature. We see a double bond somewhere, okay? By the way, hydrogen will never have double bonds, okay? Never, ever, ever have double bonds. So don't ever put those there. So you're going to need to erase an electron pair on attached or bonded atoms and draw in your extra bond. So I took away 4 and added 2 back, okay? Ignore those. Let's just get rid of them. So now I have, do I have my checks here? Let's see. Does everything have an octet? Hydrogen has its duet, top, bottom. And carbon has 2, 4, 6, 8 valence electrons. Oxygen has its 8. That's good. We go back to our check. And do I have 12? 2, 4, 6, 8, 10. Yeah, perfect. All right, so that's well drawn. So that was a little bit of a hiccup there. Okay. Try this one. This one will have multiple bonds. You can pause it if you want now. The answer is this. Okay, it should look like that. This one. Pause the video when you need to. Carbon's your essential atom. Nature favors balance. That's the answer. CO2. Okay, again, let's try this one real quick. You have 4 plus 12 is 16 valence electrons. Arrange everything around a central atom. Carbon's your central atom if it's mentioned. Give everything an octet. Everything has an octet, but I have 20. I just drew 20 valence electrons, so this is not correct. So what we need to do is erase on adjacent atoms. I'll start by erasing those. Let's put a double bond in. So I erased 4 and added a double bond back. Erasing, so that gave me only 18 electrons, so I had to do it again, and therefore that is a correctly drawn Lewis structure. Okay? Try that one. The answer to this one is okay? That's what looks like. That's what that one looks like. This one, a little bit different here. Let's do this one real quick. Nitrogen has 5 valence electron. Hydrogen has a total of 4. But I have this. And that means I lost an electron. So you got to subtract 1. That's 8 valence electrons. Nitrogen, this one kind of bucks the trend here. That's your central atom. So this is a polyatomic ion, and as a rule, it kind of breaks the rules. Okay? So just arrange them around nitrogen like you would normally do in any typical molecule. Everything has an octet. I've drawn 8 valence electrons. The only additional thing is we need to put brackets around it and put the charge outside. Okay? Try this one. Correct answer. Here we go. C2H6. There's all your choices. There you go. And we'll get to the exceptions here in class, okay? If you have any questions, email.